This is going to be a video about adding and subtracting mixed numbers with unlike denominators. Now, if you already know how to do this, you can tune out. I won't judge you. I'll just wait a sec. Okay, if you're still here, I know this is supposed to be like a Wednesday play challenge where it's like a design challenge. This is adding and subtracting mixed number fractions. I'm honestly struggling to figure out how to turn that into like a game or a challenge. So what I'm gonna do is teach it in hopefully a way that makes sense so that if you don't get it, you can watch this video and hopefully become clearer on it. I'll give you a few to do at the end in sort of, I guess, like a fun way where you can use art if you want to. That's the best I can promise you, but I'm gonna go ahead and start. You'll probably want pen and pencil. If you could write down what I'm writing down, it might help. I'll wait. Okay. I brought extra markers. I have to make sure what I'm writing is something that actually stays on screen. I'm looking at it right now. We could go this far. Okay, check it out. See, this marker, not good. Glad I brought extras. All right, I'm gonna try to make this darker. There we go. Okay, 6 plus 5. I'm gonna start with this, so why not? 6 pizzas coming to a party, plus another 5 pizzas, which maybe someone brought later because they ran out of pizza. I don't know. So look, it's 6 boxes of pizza. Now, when you picture the whole pizzas, I want you to picture that thing when somebody walks in to like a kitchen, 6 boxes of pizza and just like plops them down on the counter, okay? Steam's coming up, they're hot, it's awesome because there's pizza. Now, the boxes aren't open yet. No one's opened the box, okay? So usually pizza, right, they cut into like 8 slices a box. Usually not 4, because it's like a huge piece of pizza. Definitely not half. I'm gonna go with 8s just because reasons. All right, so we know the pizza is gonna be cut into 8s. You know what? Pizzas that come later, I'm also going to cut them into 8s just because. I'll get to more complicated problems in a minute. Every pizza in that box, every pizza is cut into 8 slices, okay? Every pizza in this box, cut into 8 slices. Now, I'm gonna go ahead, I'm just gonna take one of those boxes and I'm gonna do that thing where you just lift up the lid and it's like this brand new whole pizza there. It's fantastic. I'm getting hungry thinking about it. So if I'm going to take one of those full boxes of pizzas, I'm gonna do this. I've taken one of them and I'm opening it. When you open that pizza, it's gonna be 8 slices there out of 8 slices. The whole box is absolutely full, okay? 5 whole pizzas, which are staying closed, because you know, if you open all the pizza boxes, they get cold, it's not great. Leave these closed. And I open this guy, it's open up, all right? People are gonna start taking some. Let's say people eat, I don't know, like 3 slices out of this open box, okay? Maybe I didn't invite that many people to my party. There, all right. No, wait, they ate 3. That means 5 will be left. Okay, it's Friday. Give me a break. I'm making this video early. Okay, so they ate 3 slices. I got 5 full ones still. 5/8 of one more is just open on the counter. A few slices gone, right? Okay. Now this box, pizza, these 5 boxes that come later in the party, whatever. I mean, they're still pretty much untouched, let's say. Actually, you know what? No. For this sake, let's say, there. Somebody ate one. Now, for some reason, I want to, somebody shows up with this, and I want to combine the pizza I have already with a pizza they just brought. And since I'm somebody who cares that people, get the same size slice, I got to make sure these are the same size. Now, I'm lucky. We got the pizza from the same store. I don't know, Little Caesars, whatever. They've already been sliced into 8s. Now, I can easily add up my pizza because the slices are the same size. Now, since it's adding, I go ahead, I'm just gonna add up the full boxes first, okay, because it's easier. 5 plus 5. I know I've got definitely 10 full boxes of pizza. And now I just have to go ahead and add up what people have already eaten. The partially empty boxes, okay? Now, all the pizza's been sliced into eighths, right? So how many slices are actually left? I got 5 from that box, 7 from that box, right? 5 plus 7 is 12. Okay, 10 full boxes here, 12 slices kind of laying around. But, you know, I don't want this pizza, 12 slices just lay around. Apparently I only have a few people here, so what I'm going to do is actually, I'm going to put some of that back in the box. And I know my pizza boxes can hold 8 slices. You know what I'm going to do? I'm going to take 8 of those slices, put them back in a box. All right. So I'm actually going to take 10 boxes. I'm going to have 11 boxes now. Take 8 slices and put it back into a box. Gives me another whole box. Okay. And that left me, if I take away 8 from that 12, 4 slices left over. So I've got 11 full boxes of pizza, 4 slices out of 8 left over. It's 1/2 divided by 4 divided by 4. But anyways, okay, so that's adding mixed numbers with like denominators. These speak the same language. They're the same size. So this math actually is super easy. Now I'm going to go ahead and just like take it up a notch. Okay. Same deal. Party, pizza. You went to Pizza Hut. You got 3 full pizzas, and then like, you know, you're driving home. You're hungry because, you know, pizza inside of a car makes the whole car smell like pizza. You're hungry. All right. Now, they sliced it into, I don't know, they were lazy. They sliced the pizzas into 4s. Really big pizzas, okay? Sliced them into 4s. You ate, I don't know, 1 slice. Okay, so I guess I should say this a little differently. You've got 3 whole pizzas in the car, 3/4 of another one, because you ate a slice. It was 4 fourths. No, you ate a slice. Now, ugh, messy, sorry. It's 3/4. Okay. Now, you get home, your buddy Jeff didn't know you were getting pizzas. So he went ahead and he had gone to Little Caesars and they sliced their pizzas in 8s. He got, I don't know, he got 2 full ones. But he also was hungry. Like I said, they sliced theirs into 8s and he ate, he had a slice too. Okay. 3 full pizzas, 2 full pizzas. That is 5 full pizzas. But guess what? I'm feeding people at a party, and I don't think it's really fair if I'm giving some people 1/4 of a pizza, which is a big chunk, and other people will get little tiny 8s. So what I'm going to do is cut all of these pieces to be the exact same size. I like to think of it like they're speaking the same language, because that way it's fair. Everybody gets the same size slice. So I have to ask myself, what do 4 and 8 both agree on? What number do they agree on? And if I don't know, I could do 4 times 8, it's 32. 4 groups of 8 is 32. 8 groups of 4 is 32. I could turn them both into 32 pretty easily, but that's also a really big number, and I don't like to do extra work. 4 and 8, they both agree on, before you say 4, don't say 4. Yes, I can use 4 to get to 8, but I can't unslice pizza. I have to slice one pizza more or slice both of them more. I can't turn that into 4, so I'm like undo cutting, okay? So these guys actually both agree on the number 8, all right? If I turn this one into 8s, it will agree size-wise with this. It'll speak the same language. So I'm gonna do that. You get a 4 to turn into an 8 to multiply by 2. Guys, anything I do downstairs here, I have to do upstairs. Times 2 times 2. It's like blowing up a balloon. I can't just blow up half the balloon, all right? Now, if I rewrite that, and I will, 3 full pizzas, 6 slices out of 8. It's the exact same fraction. I just really just cut it so the pieces are smaller, okay? Plus the 2 and the 7 8s. Now, the 8s and the 8s, pizzas are the exact same size, the slices. That's fair. And now I want to dump them all together because I like to have all my pizza combined. I don't know why, but here it is, okay? I could start with the whole numbers. Since I'm adding, I can absolutely start with the whole numbers. All right, 3 full pizzas, 2 full pizzas, gives me 5. Lovely, full pizza still in the box, nice and hot. But this, easy now, it's in the 8s, but how many slices are still sitting in these open boxes? I get 6 here, 7 here. That's 13 slices sitting there getting cold. That's great. I mean, technically I am done. This is a right answer. 5 holes, 13 slices that have been cut into 8s, but again, I don't like all those slices of pizza just sitting out. This thing's improper. Numerator's bigger than the denominator. So I'm asking, my boxes hold 8 slices apiece. If I take 8 of these slices and put them back into a box, I can just leave what's left over out on the counter. I'm going to do that. 8 from 13. I'm going to take 8 of these slices and put them back into a box. So if I do that, if I take 8 slices out of there, I'm going to have 6 full boxes of pizza. And then, goodbye, 8 slices. You've gone back into the box. 5. 6 full pizzas, 5 8s of another pizza. And really, this is almost 7 full pieces. But, you know, me and my buddy, we ate some because we're hungry. And we got 6 holes, 5 8s left. So that's adding with unlike denominators. I'm going to go ahead and do one more where here I only had to multiply 1. I'm gonna do one where I have to multiply both. So here we go. Again with the pizza. Okay, sorry. I'm hungry. I can't think of a better example than pizza because you can close it up into boxes. It's just very convenient for our purposes. Okay. Me going to a party. Always a party. 1 full pizza and let's say 2/3 of another pizza. Normally you would not slice a pizza into thirds because it's weird. I mean, for real, like who cuts a pizza like that? But for this example, you know what? I'm going to leave that. For this example, I'm going to do it. And actually, you know what? I realized that actually showing this might be helpful. So really what I've got here. Okay, 1 full pizza. So that's a full pizza right there. Still slices in there, and then 2 parts out of 3. So that's what I'm bringing to the table, literally. And Jeff goes on a pizza run. We have not communicated for whatever reason. We forgot what text messaging is. He goes again to Little Caesars, and he gets their deliciously sliced into 8 sections pizza. Okay, but he got it with pineapples. It's kind of a bummer, but I'm not worried about that right now. And he only got 1. He got 1 pizza. Let's just say he got 1 pizza and he ate a slice because that's just what he does. And so he's got 7 8s of a pizza he's bringing to my party. And actually, you know what? It says show it if I do it over here. Okay. Okay, so he's got 7 8s. Now, basically what's going to happen now is he shows up, and I want to share my pizza equally with my people. It's not cool if some people get these giant slices and some people get these really tiny slices. I'm going to take a knife or whatever, little pizza cutter, get these into smaller pieces. I need this size slice, this size slice, the 3rds and the 8s to be the same, but that means they have to agree on something. Now, it helps if you know your multiplication tables. What do 3 and 8 both agree on? And remember, these numbers can't shrink. They can only stay the same or grow. I can't uncut pizza. All right. Now, I know that the lowest thing I can get them to agree on is 24. 3, 6, 9, 12, 15, 18, 21, 24. Okay. 3 times 8 is 24. And here, it's the opposite. 8 times 3 is 24. 8, 16, 24. I can turn these both into 24, and I'm just basically slicing the pizza. Now, let's see here. I'm going to go to make that into 24 times 8 times 8. Okay, awesome. But to get this guy into 24, I'm going to go times 3 and times 3. Whatever I do downstairs, I got to do upstairs. I can't blow up half a balloon. So here we go. All right. I just actually have to do this math now. The one, the whole, you stay the same. 2 times 8, 16. 3 times 8, 24. Okay. Awesome. Same fraction. I've just sliced the pizza into really small slices, 24ths. Okay, this guy though, 7 times 3 is 21. 8 times 3, 20. Geez, really? 24. Okay. Same fraction, I've just made this entire fraction 3 times bigger. I made this entire fraction 8 times bigger. Now they both speak the same language. Now I can go ahead and put all this pizza together, and I can be sure that all my friends are getting the same size slices, because that's important to me. All right, now I've got my one hole here. That's just going to be along for the ride that comes down. I haven't opened that box yet. It's 16 plus 21, 37. If that doesn't come readily to mind, make sure you just solve it on the side of your paper there. It's 37 slices, but I've cut all of them into 24. This is a giant improper fraction. One whole pizza and 37 slices just sitting out on the counter. I don't want 37 slices sitting on the counter. I'm going to go ahead and put some of these back into a box. And I know the boxes can hold 24 slices. So I'm going to take 24 of these slices and just put them back into a box. All right. Now, 37, take away 24, 13. I'll have 13 slices left out. That's cool. Okay, so I'm going to do that. I'm going to take away 24 from you. It leaves me 13 left. Awesome. And since I just put all of those 24 slices back into a box, I actually have not one whole, but I have 2 whole pizzas now with 13 slices out of 24. Okay, cool. I guess I should show you. I did add these up. I know I said it, but it's good to see it. Okay. When you're adding when you're adding mixed numbers with unlike denominators, they just have to speak the same language, and you do that with multiplying. Remember, don't shrink them back down. They either stay the same or they can grow, all right? And it's pretty good. All right, now I'm going to move on to the next thing, which is, I guess, if you understand this, I'm moving on to takeaway. So, strap in. Okay, the same deal. We're doing takeaway with mixed numbers. It's crazy easy. You just have to get the denominators to speak the same language. And you can pretty much do anything you want to them. And there's a couple ways to do these things. I'm going to try and hit them all. It's Friday, so if I make a mistake, be gracious. Forgive me. All right, so again, party in my house. I've got 6 lovely pizzas I bought. I weirdly slice them into thirds again because it's easier for this math problem. Okay, 6 full pizzas, 2 thirds and another one. Jeff shows up. Jeff brings friends. Jeff and his friends absolutely go to town on the pizza, and they have eaten, geez man, they ate 5 1/4 of my pizza. Now, I don't know how they did that because it's divided into thirds. Doesn't matter. I'm not going to dig into it. But 6 2/3, take away 5 1/4. There's a couple ways to do this. I could, right now, just try and make these speak the same language and see if I can actually do the takeaway. I think I can. Let's find out. 3 and 4, they both agree on a number. And if I don't know what it is, just do this times this times this, right? 3 times 4 is 12, 4 times 3 is 12. They will both agree on 12. I promise you that. So I gotta make this whole thing 4 times bigger. Okay, cool. Do 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 do. Cool. What I started with, exact same thing, only now I can actually do the math. Take away. Okay. Now I need to make this into 12s. Okay. So times 3 times 3. All right. So we got 5 whole pizzas and then 3 12ths of another pizza. So I'm asking a couple of things here. What I'm really concerned about, I know 6 and 5, I can do the takeaway there, that's easy. But I'm also going to subtract my numerators up here. And if this numerator's too large, that would be a problem. Right now it's not. It's 8 takeaway 3. Actually, you know what? Let me do this. Let me do the whole numbers first. 6 minus 5. I have 1 whole pizza left. All right. And 8 minus 3 is 5 out of 12. So that's probably one of the easiest kinds you're going to get, that if you just make the numerators speak the same language, and then you can just straight up do the takeaway. You don't actually have to make any of these improper, which I'm just about to get to now. I'm going to make this 1 degree more complicated, but it never really gets hard. I want to be clear on that. So, okay, let's do it. Okay, now I'm going to make this slightly more interesting. And by that, I mean I'm going to do this math, I'm going to do takeaway, but I'm going to have to take some of the pizza out of the box. It's that complicated. It's crazy easy. All right, let's go ahead and start with, I don't know, 2 pizzas. And again, with the thirds, why not? You know what? Now, somebody cut the pizza in half, okay? 2 whole pizzas, 1/2 of another pizza. Really lazy slicing. Now, somebody comes along, blah, 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 eats 1 and, I don't know, let's say, 4/5. Okay. When I start doing this, my pizza analogy doesn't really hold up very well, but look, it's 2.5, take away 1 4/5. Now, this is actually quite easy. Step 1, I really do want to make these agree. If I want to do it that way first, because there's 2 ways you can actually go about this, I'm going to do it that way first. These guys, 2 times 5, 5 times 2, they both agree on the number 10, and I think that's the lowest I can do. So I'm going to go times 5, times 5, and then I'll do times 2, times 2. I'm going to slice all these pieces into tenths. Now if I do that, I actually get 2 and 5 tenths. Because 5 out of 10 is half. Take away 1 and 8 tenths. Okay, cool. Now this looks awesome, because if I start taking away the whole number here, 2 minus 1, I can do that, it's 1. But then when I start to take away just the slices that are left over, 5 slices take away 8 slices. I can't really do that. So the problem is, I've got to dump out some slices onto the counter in order to have enough to take away 8. And that's easy, because I know in each one of these 2 boxes, it's 10 out of 10 slices. It's a full box of pizza. 2 of them, 2 full boxes. It's 2 boxes, 10 slices each. 2 groups of 10. That's 20 slices of pizza that are just sitting in a box. I'm going to take those out of the box. I'm going to dump them on the counter. 2 groups of 10. 10 groups of 2. It's 20 slices. Plus the 5 slices that are already out. Okay? 2 groups, 10 is 20. This times this plus this. This times this plus this. This times this plus this. I'm dumping out all the slices. So this times this, this times this, 20, plus 5, 25. 25 slices that have all been sliced into lovely parts of 10. Easy, because, you know, denominator never changes. That's just what I've sliced the pizza into. I've got 25 slices that have been in tenths. And from that now I can take away 1 and 8 tenths. But see, I really can't now, can I? I can't take, there's no whole number anymore here. I might as well just put a big 0 0 minus 1, I can't do that. I'm going to have to dump out this pizza too. If I'm going to, I call this impropering a fraction because I just took this lovely mixed number and turned it into an improper fraction. Top's too big, numerator's too big. If I did it to that one, this times this plus this, I'm going to go ahead and do it to this one. Goodbye. All right. Sorry. I got to make it so you guys can see it at home. Even this marker's starting to die on me. Okay. So, one full box of 10 slices right here. This times this is 10 slices plus the 8 already about. This times this plus this. This times this plus this. This times this, 10 plus 8, 18. 18 out of 10. Now, I don't have any whole numbers because I've dumped out all of the full boxes. They're gone. All the slices are just laying out on the counter. And now I can actually figure this out. 25 minus 18, well, by God, that's 7. Denominator stays the same because I haven't really changed the size of the slice. All I have left, 7/10. That's it. I don't have any full pizza anymore, just 7/10 of the box, which makes sense because, I mean, if I do the takeaway, there's not going to be a whole lot left over, right? And there's not 7/10 left over. Yeah. So, to summarize, sometimes when I'm doing takeaway, I do want them to speak the same language. Absolutely. But sometimes I have to dump out the full boxes in order to be able to actually do the takeaway. So I know this video is getting crazy long, but I just want to cover this all in one sitting. And again, if you get this, you can just turn it off like right now. But I'm going to keep going. I'm going to do one more of these, and then I'm going to do it takeaway where I improper it first, and then put all the pieces back into the box. Okay, it's easy either way. You get to pick your favorite. Okay, so let me do one more here. You can go away for a second. I'm just gonna keep erasing this. Hi. Okay, I want to do one more takeaway mixed number thing where I have to basically unpack some of the boxes, which again, you're just dumping pizza onto the counter. That's it. You've been alive for a while. You've eaten pizza. You know how this works, okay? So check it out. 5 pizzas. Do. You see that? Dude, I don't know, man. These markers, not great. Try this one. Better. Yeah, okay, you can see it. 5 full pizzas. Let's divide these into 4s. Let's say 1/4. Okay. And from this, I'm going to go ahead and take away, I don't know, 2 and, I don't know. Again, let's just go with 4/5. Okay. Awesome. This is easy. I already know that 5 minus 2 is 3. I'm halfway there. But really, I need these to speak the same language. So, what do 4 and 5 both agree on? And if I don't know, just multiply them together. 4 and 5 both agree on 20. They also agree on things like 40. You could do 80. You could. You'd get the right answer. You just have to like shrink it back down a little bit. I'm not going to cover that right now. I'm going to go with 20. It's the lowest number they both agree on. So I'm going to get you to 20 by multiplying you by 5. Whatever I do down here, you got to do up here. All right, times 5 times 5. And this guy times 4 times 4. Easy. Okay, now I just got to rewrite it. 5 and 5 20ths minus 2 and 16 20ths. Awesome, except it's not. I can do the whole numbers. 5 minus 2 is 3. That didn't change. But I can't do 5 slices minus 16 slices. So I'm doing this thing where I'm just dumping out all of the pizza. Now, here's the thing. If you really understand this, you can unpack just one of these boxes and dump it out. You absolutely could. If you dump them all out, if you do the this times this plus this, you're going to get the right answer. Like, you know what? Let me do that real quick, and then I'll just unload one of them. It's easy. Look. All right. Okay. 5 boxes, 20 slices each. 5 times 20. That's 100 slices of pizza. Plus the 5 I still have out. This times this plus this. 105. 105 pieces that have been split into 20ths. That's the size of my slice. 20 slices per box. Take away, all right, this times this plus this. So 2 groups of 20, 2 boxes, 20 slices a box. That's 40 slices of pizza. Plus, I still got 16 there, so that's 40 plus 16 is 56 slices of pizza that have again been made to be 20th size slice. All right, 105 minus 56. They both speak the same language. I can go ahead and do that math, and I don't trust myself to figure that out in my head right now, so I'm just going to go ahead and, do this. If my Friday brain is to be believed, I should have 49 slices that have been put into boxes that can fit 20. That's great. That is absolutely great. I'm going to erase some of this. Okay, cool. Now, believe it or not, that's actually the right answer. That is absolutely a right answer. But sometimes you're not going to see it in this form. This is improper. I'm going to turn it back into a mixed number. So this is really, this line, it just means dividing. 49 divided by 20. Now you could go old school and do the 49 divided by 20. 20 fits into 49 2 times to give me 49 slices left over. But I don't want to do that. I just count by 20s until I get close to 49 as possible. 20, 40, 60, 20, 40. I can make 2 boxes, 2 full boxes. I'm going to take 20 slices and make 1 box. I'm going to take another 20 slices and make 2 boxes. Okay? That's 40 slices in that box. It only leaves me 9 left over. The denominator stays the same. Can you see that? I know I'm kind of on edge here. Okay, cool. So, improper is actually the right answer. Sometimes you'll see it in that form on a test. Sometimes you won't. Sometimes you got to put these slices back into the box. And all it's saying is that if your box fits 20, how many full boxes can you make from this number? 20, 40. I make 2 full boxes, and that leaves me 9 slices. That's just going to stay out on the counter. Okay? Okay, now, I'm going to get back to what I was saying before. This is when I dump out all of the pizza on the counter. Which, you can do it. You're always going to get the right answer if you do that. But sometimes you want to be smart. Sometimes you don't want to dump out all the pizza because then you got to shove it all back in the box. What if you didn't have to shove it all back into the box? What if you unpacked just one of those boxes? In one of those boxes, in one of these full boxes, there are 20 slices of pizza. I know that because it literally says it right there. So I can just unpack one of them. And I'm going to just cross this off so I keep track of what the heck I'm doing. I have 4 full boxes. And the 20 slices I just took out. I just took out 20 full, lovely, still hot slices. And I'm going to add that to the slices already here. 20 plus 5, 25. Now, I've got 4 and 25 over 20 minus 2 and 16 over 20. I can absolutely do that now because really I can do the whole number math and then I can do the numerator math. The size slice, it speaks the same language. I don't have to touch that. So, all right, we'll do the whole number first now that I know I can do it. 4 minus 2, 25 minus 16. It's 9. And it's all been split into 20ths. So, same answer I got before. Only you have to admit, that was a little faster. I only opened 1 box. If you're not comfortable just opening 1 box and you're the dump it all in the counter type of person, the this times this plus this person, that's awesome. You're both going to get the exact same place, which is 2 and 9/20. Okay. I feel like there was one other thing I wanted to show you. Maybe that's it. Okay. If it occurs to me something else that I've missed, I think I've covered all of it. All right, you know what? I'm going to go ahead and do one last addition problem where I dump all the pizza on the counter just to show you that it works. And then I'm going to give you your little play challenge. If you want to call it that, I know this is a little bit dry, but fractions are half of the year in 5th grade and most of the year in 4th grade as well. So if you understand this, it's pretty smooth sailing. And again, it really all comes down to just knowing your times tables. So here we go. Okay, I'm gonna erase this. I'll show you that problem and then give you your challenge. Okay. I don't even know what just happened. Give me a moment to get myself together. Good Lord. Right. Okay. I don't remember which marker worked. Let's try this guy. Okay. Make it easy again. Good God. Kind of. Okay. 2 and 3rd. Yep. Okay. Yeah. Should have just stuck with this one. I knew it worked. Okay. 2 and 1/3. Plus 1 and 1/4. Now, I know in my heart of hearts that if I make these guys speak the same language, I can just go ahead and add them up, okay? I'm gonna do it real quick because I like to do this stuff. 4 and 3 both agree on 12. I could do the times 4 times 4 times 3 times 3. All right, I could do it 2 and 4 over 12 plus 1 and 3 over 12. That's glorious. Yeah, it's easy and it's fast, but I don't want to do that, even though I just totally did it. Let's just say you're so excited about turning mixed numbers into improper fractions that you just want to dump all the pizza out on the counter because it's awesome. Now, this times this plus this. I got 2 full boxes of 3 slices each, okay, plus that extra slice. So 2 boxes of 3, it's 2 groups of 3, 2 times 3, 6, plus the extra slice gives me 7. 7 slices are now laying out on the counter because you like this. Here we go. This one I got 1 full box, 4 slices. Okay, 1 group of 4 plus the extra slice on top. 1 times 4 is 4 plus 1. Slice is 5/4. Now, that's great. These are improper. This is the same thing, but I still need these to speak the same language, and they speak the language of 12. So I got to do this. Times 4 times 4 times 3 times 3, and I'm gonna get this. I'm gonna get 28 12s plus 15 12s. Cool. I got all the pizza dumped out on the counter. It's speaking the same language now, as in the slices are the same size. So 28 plus 15, what is that? 43, I think. Yeah, I think it's 43. My God, if I'm wrong, forgive me. God, 43 it has to be. Right? Yeah, okay, 43. Jeez, man. I just know if I was going to make a mistake in adding, it would be on YouTube. Okay. So it gives me 43 slices. Woohoo! I can put that in the boxes of 12. Now again, this is the right answer. This actually is the right answer, but it's a dividing problem that hasn't been solved yet. This is really saying 43 divided by 12. Yeah, and I can put these slices back into those boxes, all right? So I can fit 12 slices in a box. I'm gonna count by 12s, just start shoving them back in there. 12, give me 1 box. 24, 36, 48. 48's too high. I could do 1 full box, 2 full box, 3 full boxes. 12, 24, 36, okay? 3 full boxes, 36, 37, 38, 39, 40, 41, 42, 43. All right, and that leaves me 7 slices that had been left out on the counter to enjoy, and 12. I really just put 12 in here as many times as it would go. It could go 30, I'm sorry. it can go 3 times and give me 36. This goes into here 3 full times with 7 left over. And my answer, 3 and 7 12s. And really, again, the reason I showed you this, you can just go ahead and make these the same, speak the same language, or you could dump all the pizza out on the counter and then make them speak the same language, and you're going to get the same answer either way. Some kids absolutely just love to work with improper fractions, and to be honest, it's not a bad strategy because you can always work with an improper fraction. You can add it, you can multiply it, you can divide it, you can do takeaway, and so you can't always do that with these. So this isn't a bad philosophy, but when you're adding fractions, you don't really need to do it. Okay. All right, seriously, this is like a 90-minute video. I'm gonna give you your challenge, and here's the thing, at the end of the video, I'm actually gonna have the answers ready to go so you can check your work. Okay, let me explain, let me erase this first, hold on. Okay, if you can do these 3 problems by yourself, you're where you need to be. It's awesome. 5 and 2/5 plus 3 1/2. 4 and 4/5 minus 2 1/3. 2 1/4 minus 1 3/5. Now remember, denominators need to speak the same language, okay? Do that by multiplying. And if you're one of those people that likes to turn every mixed number into an improper fraction, this times this plus this, you can do that. If you just want to do that to all of these, you will get the right answer. It's just by the end of the problem, you usually have to take all those extra pieces and shove them back into a box. It just depends how you want to do it. If you don't need to do it, don't do it. But make them all speak the same language. Now, I'm going to show you the answers. We're going to erase this, and the answers will appear. If you get them right, awesome. If you don't get them right, you tried, still awesome. Your brain's growing. So, and if you want help, I like to teach this stuff, believe it or not. Come find me at school. I can sit you down and I can go through these, and I would really like the opportunity to do that. So, all right, I'm going to step away. If I were you, I'd pause it because I'm about to flash the answers in just a second, okay? Cool. Hey, okay, rock on. Okay, 5 and 2 both agreed on the number 10. So I made these into tens, times 2 times 2 times 5 times 5, and I got 5 and 4 tens plus 3 and 5 tens, and I got a total of 5 plus 3 is 8, 4 plus 5 is 9 tens, 8, 9 tens. Cool. Cool. I made a mistake. I'm sorry, but I don't think I did. All right, now let's take away problem. 5 and 3 both agree on 15. All right, so I did times 3 times 3, times 5 times 5. And that gave me 4 and 12 15s, take away 2 and 5 15s. Now, I realized 4 minus 2 is 2, I could do that. And then the 12 minus 5, I could do that too. 2 wholes, 12 minus 5 is 7 15s. All right, so it's done, it's good. Last one. Now, I started out by making them speak the same language. 4 and 5 both agree on 20. Times 5 times 5, times 4 times 4. And I got this. I got 2 and 5 20s minus 1 and 12 20s. And that's awesome, except I can't actually do that. I can do the 2 minus 1, but I can't do 5 minus 12. So I dumped all the pizza onto the counter. I did 2 groups of 20 slices each, 2 full boxes of 20, plus the 5 left over, you know. This times this plus this give me, yeah, I almost just said 20, it's 45. This times this is 40, plus that 5 is 45 20ths. And then I also unpacked these. This times this, 1 box of 20 slices is 20, plus 12 extra is 32 slices. So I got 45 minus 32, and they, again, it's 20 slices in a box. It doesn't change. I got 13 out of 20. And actually, I don't have, like, this isn't improper. I don't have to put any back into a box. I don't even have a full box. I have 13 slices out of 20. And that's correct. So anyways, yeah, fractions. This wasn't a blast, probably on your end. I do like to teach this. But again, if you have trouble on this stuff, please find me. And thank you for taking the time to make it all the way through this video. If you're hearing me right now, rock on. So, all right, that's all I got for you this week. I'll see you next week with hopefully something a little bit more, I don't know, game-like. All right, see you guys.